Looks like we got the last podcast of Chapter 3, Dr. Boyer.
Mr. Bergman, I can't believe how far we've come in just one chapter.
Wow.
This
Learned
is
a lot about light, haven't we?
It is. And astronomy is all about light.
Yeah.
But there's a problem.
Yeah, we live on a world with an atmosphere.
That's unfortunately, well, fortunately for us, because we need it to breathe, but for astronomers, it's a problem.
It creates problems because there's a barrier. When you're studying light, and you point your telescopes and your spectrometers at the sky, there's the atmosphere in the light.
That's right, between us and the light.
So that creates all kinds of problems. And so today we want to try and see if we can figure out what those issues are. So gases in the Earth's atmosphere absorb electromagnetic radiation to the extent that most of the wavelengths from space do not reach the ground.
Ooh.
So we've got the Earth, guys. Okay? And around the Earth we have an atmosphere filled with all kinds of gases, oxygen and nitrogen, all kinds of things. And when the sun comes, or the rays of light, not just from the sun, but from any object, most of them bounce back.
That's right.
Or they're absorbed. They don't ever make it to you on the Earth. And so when you're trying to analyze the light, you can't see all the light because a lot of it never makes it to the Earth.
That's right. So,
that's a problem.
So what can you see from the surface?
Okay.
That's the question.
Turns out we actually have ways that we can actually, make a telescope and put it in space,
That's
which is
right.
actually a topic for the next chapter. So visible light, most radio waves, some infrared, penetrate the atmosphere. That's the stuff that gets through.
That's it. And everything else, well, pretty much blocked.
So if we're trying to analyze all of the light,
Can't do it.
we
Not
can't
from the ground.
do it from the ground. So there's a lack of what are called atmospheric windows at the other wavelengths. This is the reason astronomers place telescopes in space.
Yep.
You've heard of the Hubble Space Telescope,
Oh.
which actually is just a visible light telescope anyways. But there's also, isn't it just visible?
It does a little infrared, ultraviolet,
But
but
not
not
much.
much.
But there are other telescopes, you may not know this, and we'll talk about this in the next chapter, that are that are in space, that are not visible light telescopes.
That's right.
Chandra and...
They look at gamma rays, X-rays, ultraviolet, infrared, microwaves.
Yeah, and
wow.
that's, our whole next chapter is about telescopes.
Yeah,
So
it's
we'll talk
fantastic.
about these very specific telescopes and their very cool pictures that they have made. So,
Here we go.
so Dr. Boyd, talking about this picture, this is in their textbook, but
Well, first of all, this is just a picture right here of all of these objects in space
Right.
sending their light to us, and unfortunately the light's going through the atmosphere. And certain lights will get through, and certain ones, well, they just get stopped completely, never make it to the ground.
and so we have like this graph at the top. Let's zoom in on
This thing is the important one right there.
it. So let's zoom in on that graph and see what that tells us. So talking about this graph.
Much better. Now, here is the wavelengths
Okay,
of
wavelengths.
the light.
So this is like the electromagnetic spectrum.
That's exactly what it is. And see, we're starting with X-rays, and we go to longer wavelengths. Here's our little visible. Then we have our infrared, and then radio, and then the extra long wavelengths. And look at this graph. Wherever the line is high, it says you're blocked.
So if I have some light that's coming to the Earth from space, and it hits right at this particular wavelength,
It's not getting through.
it'll never make it to the Earth.
Never, never,
So
never.
which ones make it to the Earth?
See where the graph dips down? These are the ones that can make it in. And
Okay.
of course, the closer the line is down to here, the
easier.
more gets through.
Okay.
And then you can see there's a huge barrier right here that blocks things completely. And then down here, nothing gets through. But this is really neat. Radio waves make it through. And we have radio telescopes on the ground that look specifically at this. And that's neat because radio telescopes are huge, very expensive to put into space.
So basically, there's just a few wavelengths that we can see, guys.
That's right.
From the ground, not from space. From space, you can see everything.
Space, you can see everything.
But from the ground, we can see this huge radio window, the visible window, a little window in the infrared called the infrared window, etc. So very few things get to space. Hence the need for telescopes in space.
That's right.
Well, guys, that's the end of chapter 3.
Yep.
Chapter 4, we're talking about telescopes, and so in that chapter, we'll learn about all these telescopes in space and how telescopes are designed It's pretty cool. So, and then we'll learn after that what we've learned about from our telescope.
That's right.
Okay. We'll see you in class.